Alright, so we have three equations here with three unknowns, x, y, and z, and we are going to solve for the unknowns using a matrix. So just as a reminder, matrix form, ax equals b. So here, we're going to rewrite this. So a is x plus y minus z, so 1x plus 1y minus 1z is equal to 6. And then same for the ones below, so 2, negative 1, 3, 4, 2, negative 3, x, y, z is equal to 6, 11, 14, right? So this is our A, this is our X, this is our B, and A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. Coefficient, variable, and constant. All right. So how are we going to solve for x, y, and z? What we're looking for at the end of this, we're going to create a augmented matrix that looks something like this. This is what we're going to end up with. What's going to help us. So now let's create the augmented matrix based on our equations. So that augmented matrix is 1, 1, negative 1, 6, oops, 2, negative 1, 3, 11, and then 4, 2, negative 3, 14. All right, so how do we go about getting this stuff, this guy, to look like this guy? We're gonna approach it step by step, row by row, by using what's called a pivot. So we're going to use this first pivot, which is row 1, column 1. It's looking how we want. It's already a 1, which is great. And we're going to eliminate below this first pivot. We're going to get these two rows, these two places, if you will, to be 0. So how are we going to do that? Well, we can use Gaussian elimination and transform each of the rows. So if we do, let's do red, green, blue. So this is row 1. Let's set these markers up. Red, green, row G, div. Row 2, and then row 3. Oh, that's purple. A blue cat. Okay. So how do we get 2 to become a 0? Well, we can do, oops, that's a 2. We can take row 2 and change it to row 2 times 2 minus row 1, because what's 2 minus 2 times 1? It's 2 minus 2, which is 0, which is what we're looking for. So row 2 is going to become row 2 minus 2 times row 1. Oops. Grab my coefficient. 2 times row 1. And row 3 is going to become row 3 minus 4 times row 1. row 3, row 3 minus 4 times row 1. Because what's 4 minus 4 times 1 is 0. That's what we're looking for. So let's create our new matrix based on these transformations we're going to do. So row 1's the same, 1, 1, negative 1, 6. Row 2's 2 times row 1. So 2 minus 2 is 0. Negative 1 minus 2 times 1. Negative 1 minus 2 is equal to negative 1 minus 2 is equal to negative 3. And then 3 minus 2 times negative 1 is equal to 5. Because it's 3 minus negative 2. 5 becomes positive. Lastly, 11 minus 2 times 6 is 11 minus 12, which is negative 1. Alright, so we have that all done. Now let's do row 3. To make this a little easier, I'm just going to rewrite. I'm going to rewrite right here 4 times row 1 just to help us. 4r1 is equal to 4, 4, negative 4, 24. This will help us just do the math out easier. 4 minus 4 is 0. 2 minus 4 is negative 2. Negative 3 minus negative 4 is negative 3 plus 4, which is positive 1. And then 14 minus 24 is negative 10. All right. Cool, so we've done these two transformations, and now everything below our first pivot is 0. 1, 0, 0. So this first column is all set. So now we're going to move on to the second column, second row. We're going to look at this second pivot, and we're going to eliminate everything above and below that pivot. So we're going to transform this so that eventually here and here is equal to 0, because that's what we're looking for there, right? How can we do this? First, we can simply just divide row, what's row 2? Row 2's green. If we just divide row 2 by negative 3, we'll simplify this to 0, 1, negative 5, 3, 6, etc. So let's do that real quick. So did I say row 3? I meant row 2. Row 2 is going to become row 2 divided by negative 3. Black. Everything else is the same in the other rows. 1, 1, negative 1, 6. 0 divided by negative 3 is 0. Negative 3 divided by negative 3 is 1. 5 divided by negative 3. And then negative 1 divided by negative 3 is positive 1/3. All right, what's our next step? We're going to now that this is simplified, we're going to work on eliminating above and below the second pivot. So what we can do is transform row 1. It's going to become row 1 minus row 2. Why are we doing that? Because we want a 0 here, and this 1 minus 1 is 0, so it'll work out that way. And then we also want a 0 here, right? So we're also going to change row 3 that first. Can we do this at the same time? Yeah, this will work. Row 3 is going to become row 3 plus 2 times row 2. Because if we take negative 2 plus 2 times 1 is negative 2 plus 2, which is 0, which is what we want. So that will work. So let's create the new matrix based on that. Oops. That's not what I mixed up my caps. So row 1 is row 1 minus row 2. So 1 minus 0 is 1. 1 minus 1 is 0. Negative 1 minus 5/3. Let me write that out. Negative 1 minus negative 5/3 is negative 1 plus 5/3, which is negative 3 over 3 plus 5 over 3 is equal to positive 2/3. And then 6 minus 1/3 is 18 over 3 minus 6 is 18 over 3 minus 1/3. Just using fraction form is 17 over 3. 6 minus 1/3. Cool. Row 2 we are not changing, so let's plug that back in. Row 3 is becoming row 3 plus 2 times row 2. So just to help us, let me just write this guy out here. So 2 times row 2 is 0, 2, negative 10 over 3, 2/3. So 0 minus 0 is 0. So, 0 plus 0 is 0. Negative 2 plus 2 is 0. 1 plus negative 10/3 is negative 7/3, should be? Because 3 over 3 plus negative 10. Yeah, negative 7/3. And then negative 10 plus 2/3. Negative 10 is negative 30 over 3 plus 2/3 is negative 28 over 3. All right, we're almost there. The second column looks good. We have now eliminated above and below that pivot. So now we're going to work on to looking at the third pivot in column 3, row 3. So this next one will be pretty easy. We're just going to take row 3. We want a 1 here, right? How are we going to get 1? We can multiply by negative 3 over 7. So row 3 is going to become negative 3 over 7 times row 3. 1, 0, 2/3. Zero times this is 0. Again, negative 3 over 7 times negative 7 over 3. Cancel each other is equal to 1. And then negative 3 over 7 times negative 28 over 3. The negative signs cancel each other, right? Positive. And then the 3's cancel each other, so now we just have now we just have 28 over 7, which comes out to 4. Makes it pretty easy. Yay! So now the third row is looking pretty good. We have 0, 0, 1, which is what we want. So now the last steps is just getting rid of everything above this third pivot. Our third pivot's right here. So now, the last 2 steps, we can change row 1. It's going to become row 1 minus 2/3 times row 3. Because we have 2/3 here, and if we subtract 2/3 times 1 here, that'll get us the 0 we want. So that's why we're multiplying by 2/3 and then subtracting. And then row 2, green, is going to become row 2 plus 5/3 times row 3. And again, because we have negative 5/3 here, we want to add 5/3 to that to get to 0. So we can get 5/3 by multiplying this by 5/3. So 2/3 I'm going to write these out real quick just to help us so we don't have to do all the mental math. 2/3 R3 is equal to 0, 0, 2/3. 2/3 times 4 is just 8/3. 5/3 R3. Pretty similar. 5/3, and then 4, 23. All right, so let me stand on this side. 1 minus, looking at row 1 right now. 1 minus 0 is 1. 0 minus 0 is 0. 2/3 minus 2/3 is 0. 17 over 3 minus 8 over 3 is 9 over 3, which is a nice even 3. Alright, and then let's look at row 2 now. 0 plus 0 is 0. 1 plus 0 is 1. Negative 5 over 3 plus 5 over 3 is 0, which is what we want. And 1 over 3 plus 20 over 3 is 21 over 3, which comes out to a nice even 7. Yay! And then let's plug in our row 3, which we left unchanged. Yay! So now we have the augmented matrix that looks like what we were looking for. Everything's reduced, all the pivots, everything below the first pivot, everything above and below the second pivot, and then everything above the third pivot is all equal to 0. So this comes to our solution is 3, 7, 4 is equal to x, y, z. So x is equal to 3, y is equal to 7, z is equal to 4. Are we done here? No. It's always important to double check the equations at the beginning. So let's just plug them in real quick, make sure that everything works out. So let's start. So x plus y minus z equals 6. X plus y, 3 plus 7 minus z equals 4 is equal to 6. Is that true? 10 minus 4 equals 6. Yes, that is true. It works out. 2 times x is 3 minus y, which is 7, plus 3 times z, which is 4, is equal to 11. If we distribute, so 6 minus 7 plus 12 is equal to 11. 6 minus 7 is negative 11 plus 12 is equal to 11. Yes, that is true. That also works out. Last one, 4 times x. X is equal to 3 plus 2 times y, when y is 7, minus 3 times z equals 4 is equal to 14. We're going to distribute everything. 12 plus 14 minus 12 is equal to 14. 12 minus 12, those cancels out. Does 14 equal 14? Yes, it does. Nice. So our solutions using the matrix method, x, y, z, that's how we found the unknown variables in the 3 different linear equations.